all from one class. That's the amazing thing. It must be a really large class this year. So it's good to see so many different folks, students, faculty, and some folks from the community here. This is very gratifying. My name is Josh Mizell. I'm one of the co-directors of the newly formed Humboldt Institute for Interdisciplinary Marijuana Research. Our mission is to support, to encourage, collaborate, disseminate research examining the social, economic, public health, ecological, and so on and so forth, implications of marijuana not just on the North Coast, but in society at large, in the broader community. And we draw faculty from a variety of different disciplines at HSU, and we encourage student involvement for those who are interested, and we encourage conversations with the community as well. So it's great to see so many folks here. I want to especially acknowledge and thank the generous support from the College of Arts, Humanities, and Social Sciences, the College of Professional Studies, and the College of Natural Resources and Sciences for sponsoring this speaker series. This is the second in a seven-part speaker series that'll be running through April. You can find our schedule on our website. We now have a website. It's very exciting. It's humboldt.edu/HIIMR, and you can get information about the other speakers. I can tell you we will be having Jason Plume from the Department of Politics will be speaking on of green institutions and incremental policies, marijuana regulatory reform. Very different focal point than our speaker this evening, but it's important to note that that talk will be presented following the election, and he's going to be speaking specifically around some of these referendums, specifically I believe in Oregon and Washington, if that's correct, Jason. I know you're
Colorado.
over here. Am I accurate in that? Does that sound about right? And all of our talks are in the same space, either on Monday, Tuesday evenings at the same point. Same time we. Can somebody let these folks in the back there? I wasn't able to unlock that door, so you've been deputized as the official door opener. Thank you very much. So I'm going to introduce my colleague Rick Brown from the Department of Wildlife, who will be introducing our speaker. Rick is an associate professor in the Department of Wildlife. He's taught a number of classes at HSU since arriving in 1996. Principles of the Wildlife Diseases, Advanced Disease Lab, as well as a beginning course on animal welfare and wildlife policy. He's also a wildlife disease ecologist and wildlife veterinarian. Most of his research is focused on the ecological maintenance and transmission of tick-borne diseases, as well as pathogens transmitted through carnivore communities. I'm reading what I'm reading what he sent to me. He's working. Thank you. On the study, the effects of pesticides or other toxins on wildlife. And it's important to note he not only likes, but he loves his job. Right?
I do.
He does. Okay. So without further ado, I want to introduce Rick, who will be introducing our speaker, Mourad Gabriel.
All right. Thank you, Josh, and thank you, everybody, for showing up. I have a couple of announcements before I get going and forget. One is we're going to meet at Rita's tonight. For people who are really interested, please come join us for a no-host dinner or whatever you want to buy for yourself. That'll give you a chance to talk to Mourad and get to know Greta and then get the dirt on Mourad. I usually try to give short introductions when I introduce people, and I'm going to try to do this fairly quickly, but I think I can say a couple of things that will actually help you interpret what Mourad is going to talk about today and help you interpret his credibility, if you will. I want to start by saying that Mourad is a really interesting guy. He got a bachelor's degree from our Department of Wildlife a long time ago. I've known Mourad for 12 or 13 years. He was then accepted as a graduate student under Rick Bachelor, who was a wildlife disease biologist. His master's degree working on a tick-borne disease called human human granulocytic anaplasmosis, and the ecology of that pathogen in gray foxes and domestic dogs at Hoopa. While he was an undergraduate and while he continued on as a master's student, he was one of those students that was actually so enthusiastic that he created his own company along with his wife, MGW Biological Surveys, and they continued to do a lot of work on species of conservation concern, especially. Following his graduation with his master's degree, Mourad and Greta started a non-profit, the Integral Ecology Research Center. I'll refer to it as IERC. You'll probably see it on some of his slides. Again, that's something that most people don't do coming straight out of grad school. I think he's a very unique person in many ways. I don't say that lightly. He's incredibly enthusiastic. He is somebody who has a passion for natural resource management that goes above and beyond what you normally see. And in this program, and our program in wildlife, and our natural resource, College of Natural Resource Sciences, we have a lot of people who are really passionate. And I think tonight you're going to see something of Mourad's passion, which to me always stands out as remarkable. He's very thoughtful and very creative in his work. He's somebody who thinks outside the box. He's somebody who also, and I hope this comes out tonight, I think that this is one of the most unique things about Mourad in a way, is that he's very ethical and very thoughtful. And he's taken an ethic to heart that was promoted, it's been promoted by a lot of biologists, but including his master's advisor, Rick Bachelor. And that's, in a nutshell, the idea that if you're going to capture and handle wildlife and put them through that risk of capture and maybe anesthesia, you collect as much data from them as you can. And you utilize that data to your greatest potential. So Mourad did all the things that a good grad student's supposed to do. He worked real hard. He came out with a good thesis. He published his thesis. And that's usually where most good graduate students stop. But Mourad, because of his willingness and interest to utilize samples, probably got another 4 or 5 papers out of samples collected during his master's work. Again, because he's a go-getter, he's energetic, and he has that passion to try to get as much as he can out of his work. Following his master's work and starting this nonprofit where he was working on fisher diseases originally, Mourad took that project into his Ph.D. at UC Davis, and is now moved from being somebody who was working on fisher diseases to being somebody who's probably one of the authorities throughout North America on fisher diseases. Mourad doesn't have his Ph.D. yet, so when you make that statement, I think that's pretty unique. In terms of thinking out of the box, one of the things that Mourad did, he's going to talk about tonight, that isn't part of his, well, wasn't part of his Ph.D. dissertation proposal. I'm on that committee, and so I know his proposal, and it didn't say anything about toxins. But as Mourad worked through his samples and was working on projects, he started getting ideas that some of the stuff with the rodenticides might be important. And he and pathologists and toxicologists worked together to develop this story that was published in PLOS One 4 months ago, something like that. And it's now taken the world kind of by storm, at least part of the world, I think. He's published quite a few articles, a lot more articles than you would expect, or papers than you would expect from somebody with a master's and as a PhD candidate. He's published 2 book chapters. He, along with Mark Higley, raise your hand, Mark. Mark's a biologist at Hoopa, who helped Mourad and has helped a lot of wildlife students, great field biologist. Mark and Mourad just spent 3 days in Washington, D.C., talking to the heads of a few of the different departments, including the Office of National Drug Control Policy, the Department of the Interior, U.S. Department of Agriculture, etc. I think for any biologist working at any level, to spend 3 days in Washington talking to the very top level administrators, I think that that's something worth noting. I think for a PhD candidate, that's just an amazing last things I'll say is that he's lived here quite a while, lived here for 15 years. He uses natural lands or wild lands and public lands regularly, both for sport and because he works on those lands. And I think I'm just gonna shut up and let Rod talk, since he almost has his Ph.D. As committee member, I'm trying to get him to turn those last chapters on. I'm going to introduce him as almost Dr. Mourad Gabriel.
Thank you, Rick, for that kind introduction. As Rick mentioned, a lot of this work, whatever I'm going to talk about today, I like to right off the bat give a caveat that all of this research is not solely on my shoulders. This is a collaborative interdisciplinary research that could not have come to fruition if it wasn't for the collaboration with academia, state, federal biologists, NGOs, and really good close friends. So this, I'm standing up here, but again, there's multiple individuals here in this field, in this room, that also deserve to be up here explaining what we're finding. Let's see. Well, first off, I will be not just discussing how toxicants associated with illegal marijuana cultivation is impacting wildlife on our public and tribal lands, but I'll also be explaining other direct and indirect impacts that this illicit activity has on wildlife, our budgets, and safety too. So, is this a marijuana talk? Am I going to be discussing specifically only the plant marijuana or cannabis? And no, this talk is focusing on toxicants associated with an illegal activity and its impact on the wildlife as well as their ecosystems. The other common question I get is, well, illegal activity, but you're talking about Proposition 215, medicinal marijuana. And I like to highlight that it is a criminal act to cultivate corn, strawberries, or cannabis on any of the public and tribal lands without the steward agencies or the public's permission. So what I mean by this is, take for example a national park or Hoopa tribal community lands. So these are timberlands that belong to the community. It would be illegal for anybody to come in there to just drop their tractor, start planting corn, disking up the field, terracing the soil, damming up water courses for their crop, put massive amounts of fertilizer, not 10s, 20, or 100 pounds. We would wish that amount, but thousands of pounds of fertilizer. And then on top of that, bring banned chemicals or restricted use chemicals or regulated chemicals, but use it in an illicit manner on any of these lands. So again, the point of legalization for this particular talk would be moot, simply because it would be illegal to do these actions, whatever type of agricultural product it might be. As Rick mentioned and Josh mentioned, a lot of this stems from a recent publication that came out. It was in July 13th of this year. And we dealt with specifically only one toxicant, so anticoagulant rodenticides. And we focused only on public or community lands such as tribal lands on Hoopa. And we looked at exposure to this toxicant within a rare forest carnivore. And if you want to find the paper, you can easily Google search it. So just type in PLOS1 Fisher or PLOS1 anticoagulant. It should pop up in the first one or two search parameters. Also, you can go to our website, and there's a couple other reports that we have specifically documenting this. as well as some slideshows that we have presented so that you can download those and utilize those too for your own presentation. But also the other thing too is we published this in an open access journal. So one thing is really beneficial, and I think a lot of our co-authors have found out that this has been highly beneficial, is to disseminate this information further beyond the scope of, let's say, Humboldt County or within our field, is PLOS One is an open access journal. So therefore anybody not, and they don't have to be affiliated with academia, can actually download this article. The whole article is also available in a PowerPoint format, and all the photos are in high resolution JPEG format too. So you can download this and actually do a PowerPoint presentation, and it also there's a discussion format. So if anything you see in this paper that you see is questionable or raw data is out there to be scrutinized, in addition to that, you could also start a communication with any of the co-authors there, and we can start having a further discussion about any concerns or other ideas. So this article generated a lot of media. Just basic searches, we have over 180. I just did one the other day, and I think it's about 180 to 190 national media instances. So we had NPR, California Watch, CNN, NBC. It went through CBS Evening News to all the way NPR to actually Rush Limbaugh even discussed this paper.
I wish I didn't know that.
Yeah. Well, he had a funny spin to it. In addition to that is international media. It's about 50 to 60 international media sources have also picked this up. And then we also have, of course, with anything with media, we have very creative. So marijuana farm poison is killing furry little animals in California. So we have very creative titles. So again, what I don't want to do with this talk is sensationalize or emotionalize this issue, because we have to approach this issue objectively and very neutrally to address, inform agencies, and also educate the public on what's going on. Right off the bat, let's just go over what a fisher is. So it's a forest specialist mesocarnivore. Its habitat essentially is a mid to late stage coniferous forest or mixed coniferous forest. So you don't find, East Coast, you might find fishers around agricultural or urban settings. However, on the West Coast, fishers do not reside in agricultural, so they're not in downtown Sacramento. They're not on the outskirts of the foothills of Chico. They're actually in mid to late stage coniferous forests that you might find in your national forests, national parks, or timberlands, private or tribal timberlands. They're omnivorous, so they have a wide array of prey items. So they go from lizards, rodents, rabbits, all the way to acorn, manzanita berries, blackberries, Himalayan blackberries. So they consume a wide diversity of prey. Also, males tend to be fairly larger. So you'll have a male that's 4 to 6 kgs, and then you'll have a female at 2 to 4 kgs. The one item too is also to note is that they mate and they raise their young between the months of March and June. So this is a very key point, which I'll illustrate in a subsequent slide. The conservation status of fishers currently within the western states, so this is Washington, Oregon, and California, they're warranted for listing under the Endangered Species Act. The determination, I believe, is going to be 2014, whether either to remove them, place them on, whether as a threatened or endangered species. So that's upcoming, and there's more data being analyzed, published, and presented to make that determination. But however, as you can see here, the gray area is where fishers, the historical range was. So they've extirpated or became locally extinct in Washington, Northern Oregon, and multiple places also throughout the Sierras. This is actually a very liberal estimate of their current status and their distribution. People believe that they've actually contracted from this last map. But in some recent research, just to show the population status, for example, in Northern California, it hasn't been firm and set. It hasn't been determined on what the population size may be. But it's estimated on the isolated southern Sierra Nevada portion, which we also worked on, our collaborators, it's estimated to be about 120 to maybe 250 adults. So the population isn't that large. We're not talking now thousands and thousands of fishers in this one isolated population. The next question is, how did we get to a fisher, in this case is a dead fisher, and making that link to rodenticides, so a toxicant, a rat poison, anticoagulant rodenticides. Again, like as I mentioned in the first bit of my talk, is collaborations. It's building up this interdisciplinary collaboration from a multifaceted approach. So we had toxicologists, pathologists, ecologists, taking this all, and as you can see here, what occurs on a lot of these projects is you have a field crew, field ecologist capturing a fisher. We take health samples, just a baseline health sample so we can analyze it in the future. And then we'll put a collar, whether it's a GPS or a VHF collar, but then we can monitor this individual throughout its life. And then when it dies, it would pulse out a signal at a certain interval and a certain time, so we know that there's a mortality signal. That would key in the ecologist to go out in the field to collect this sample or this fisher so that we can bring it into the lab to determine the proximate or ultimate cause of mortality. So you have a fisher that just died, and essentially what we do post-mortem is we do a full suite necropsy. So that includes gross necropsy, histopathology, and in addition to that is lots of loss of ancillary testing, which also includes toxicology screening. The paper focused on only one toxicant, which is anticoagulant rodenticide. Essentially, it's a poison, it's a chemical pesticide, comes in pellets or bait blocks, has a lot of flavorizers. It's a vitamin K antagonist. So essentially what it does, it binds vitamin K. So all of us here, we recycle and utilize vitamin K as well as other clotting factors. So this pesticide specifically binds and targets that, inhibits it, so therefore we can't recycle it, it's not available, and what happens is the constant presence of this pesticide, when you get to a certain level and it disrupts normal blood clotting parameters, then it causes bleeding or hemorrhaging. So take it, for example, a vessel in yourself. When all of that's bound, that becomes a sieve. There's nothing to hold that blood within the vessel. So hemorrhaging is considered a very, very excruciating, painful death. It just leaches out into the cavities, thoracic, bleeding from the eyes, nose, mouth. It's a very painful death. Flavorizers. This is actually something that, with all my classes at Humboldt State, I would have never it's something that you learn, and you never would have known that all these manufacturers incorporate tons of different flavorizers because the toxicant is unpalatable in its bitterant. And so I'm only highlighting several flavorizers. The gamut goes from apple, cherry. So you have peanut butter, cheese, bacon. So now when you have all these different flavorizers, you run the risk of what we would have expected just with the toxicant itself. We would have expected only secondary poisoning. So a rodent being exposed, that marten or a fisher or any other carnivore or terrestrial or avian would consume that rodent, and that would be a form of secondary poisoning. However, now with these flavorizers, we have to take in consideration the possibility of a primary poisoning occurring. So that's just them going directly eating a bait block that may taste like bacon. Really quickly, there's two different types of rodenticides. There's first and second generation. So first generation is something where many of us are very familiar with, is warfarin. It's metabolized fairly quickly. It pulses in and out of our systems if you're consuming it fairly fast. And it also takes multiple feedings. So you might get a rodent and you might have warfarin on the ground, and that rodent will have to consume it for multiple days and possibly weeks at a time for it to reach a clinical threshold that it actually starts to bleed out. However, second generation, which is what people are considering super lethal warfarin or super rodenticides, these are acutely toxic. The retention in tissue is greater than 150 days. There's some cases that it could be up to 220, 280 days, and that's the half-life. So extrapolating that for it to dissipate fully out of an animal system, if and only if that animal never becomes exposed to that toxicant again, it could be years before it actually fully pulses through that system. And a single feeding can lead to mortality. So there's very few studies on these toxicants, but there's one study where they've actually placed second generations out for Norway rats. And these Norway rats consumed 70 lethal doses before they died. So just to put that in an ecological context, is that if that were to occur and you were to have a fisher consume that wood rat or that squirrel, there's that possibility that that wood rat or that squirrel would be extrapolated to that fisher consuming 70 different poisoned rats, because the doses are building up. It's being sequestered and it's not being able to metabolize it, and it might not die for about another 5 or 7 days later without fully metabolizing it. So the project areas for this particular study was in Northern California, the two isolated populations in California. So Northern California and the isolated small population in the Southern Sierras. Again, highlighting all of the fishers that we tested, we knew where they were on the landscape. Some of them we knew from birth to death. So it's not like we just opportunistically picked up a fisher and we didn't know where these were. We knew on the landscape level through the GPS telemetry where they were, whether on a forest land, agricultural land. We could put that in determination on the spatial and the landscape scale. So the results, right off the bat, we tested 58 fishers, 79% of them were exposed. We had 4 mortalities for this publication. Remember when I was mentioning that the fishers mate and raise their young between those months, between March and June. All fisher mortalities occurred during those time period. In fact, one of the fishers was a female fisher, which we knew she had kits and suspected to have 2 to 3 kits. So that fisher female died, and we would expect, because all of them were still milk dependent on her, died from starvation or exposure, because the mother was, the mortality was through rodenticide poisoning. Now, when we tease that apart to see the differences between the warfarin, so that's the first generation, versus the second generation, it's clear to see that the number one toxicant or poison on board was the second generation brudificum, which is commonly found in packages like this as decon. And when we look at the differences of the numbers of rodenticide on board, we have 1.7, that's the average, is 1.7 different rodenticides on board. We had a range of 1 to 5 different rodenticides. So we had fishers up there that had 2, 3, 4, 5 different rodenticides on board in the tissue within that same animal. Now, working with board-certified toxicologists that have done a lot of wildlife work, when we started getting this data, the first thing I asked them is, have you ever seen 4 or 5 different rodenticides? And they've mentioned, this is unheard of. Typically, you'll find 1 or 2. So there might be somebody who misused 1 or 2 different rodenticides in adjacent farmlands or in an urban center. But 5 different rodenticides, that's actually very surprising and very alarming. And one thing to add is, no one knows what the potential additive effects are when you have 1, 2, 3, 4, 5 different rodenticides on board, all working synergistically potentially towards binding the vitamin K or other clotting factors. This is all unknown. There's been absolutely no experimental data to say that this may not have an additive effect. However, talking with, we work with Bob Popengay. He's a toxicologist at UC Davis, and Bob strongly suggests that he believes that this possibly can be an additive effect. So on the landscape level, as I mentioned, we know where these fissures were. The yellow dots represent exposed individuals, the red dots are mortalities, the greens are non-exposed. You can clearly see here that finding green dots within the landscape are few and far between. Yellow dots are from the Shasta T National Forest, Six Rivers National Forest, and because one of the projects was focused specifically on Hoopa tribal lands, and the principal investigators were Sean Matthews, another Humboldt State alum, and also Mark Higley, a Humboldt State alum. You can see their project area was significantly impacted by these toxicants. Now, this actually highlights it even further, that just on the landscape level, and this is Sierra National Forest and Yosemite National Park, which is the polygon up on the top, you're hard-pressed to find green dots, to find fissures that have not been exposed. We had 4 fissures that we know that lived their entire life within Yosemite National Park, and all 4 of those fissures were exposed to an anticoagulant rodenticide. So again, this toxicant does not see boundaries. It's not only on timberlands, and it's not only on Forest Service lands or only in parklands. It's throughout any of these public or tribal lands. This is a very, very surprising data point that we were able to come across. We had a fissure kit that we knew the female actually died from vehicular strike. So the ecologist climbed the tree, removed the kit, and unfortunately the kit died. And when we tested, it actually died within the den cavity, so it actually died in the field. So when we did a necropsy, in order to determine the cause of death, it died of starvation of exposure. But this kit was less than 6 weeks of age. It was 100% dependent on its mother's milk. This is one of the first documentation now of mother milk or transplacental transmission of a toxicant within fissure kits. So this is drawing very much parallels to other toxicants such as DDT that are possibly now starting from within womb, the possibility of bioaccumulation. That fissure kit, if it were to survive and its mother didn't die, that fissure kit now started day 1 exposed to that toxicant. So throughout its life, if it were to be exposed, it can continuously accumulate on board these poisons. Now, when we try to highlight what does this mean on the impact directly to a fissure, so one individual, we put this photo and we documented this in the paper, but it really highlights the gross impact that occurs of hemorrhaging. So this one fissure died, and let's just say it had 340 milliliters of blood volume. It lost 72% of its blood volume within its abdominal cavity. I'm not even counting the thoracic cavity or the blood from its anus, its eyes, its nose, its ears. There was constant blood coming out. So I'm not even incorporating that. So it's most likely over 72% of its blood was leached out through this hemorrhaging. Now, has this exposure to this toxicant gone away? There's been some recent EPA regulations, and some folks think that it might have completely dissipated and have gone, or has the mortality subsided? And unfortunately, no. Exposure rate now, post our study, is now up to 86% from 79%. We have now 6 confirmed mortalities. We have 2 more that are highly suspicious of dying from rodenticide. We also have another individual from Northern California that we suspect has directly consumed rodenticide. That was one of our fears of these fissures now coming into these grow sites and consuming the rodenticide directly. And we have a case of this. Let's see if this works. Oh. So what I'm going to show you is a video that Mark Higley has been able to provide me, and it's actually something that when this occurred, this was a fissure that we suspected of poisoning, and we had to make the determination after consultations with a pathologist and a toxicologist to euthanize this fissure. There it is. So this is a fissure stuck in its habitat, and you should not be able to handle a fissure like that. Non-anesthetized. So there's no drugs on board on this fissure. That fissure, if you were to see a clear example of this is in 60 minutes, there is, I'll go into other toxicants, but in 60 minutes, there was a case where toxicants were being misused, and the symptoms that we're seeing in this fissure almost directly mimic what was been documented in African lions and other African carnivores. So again, as I mentioned, this fissure, we had to euthanize it because at this point, at this level, when it's occurring like this, there is no supportive therapy, there's no care, and it's either dying a very painful death or making the choice of euthanizing it to take it out of its suffering. And after consultations with multiple individuals, we came to that conclusion. So the point sources of AR, we had to take in possibilities, rural cabin settings, power pole protection, so power companies, or timberlands. These are all logical potential sources. However, again, second generation, that was 96% of the fissures were exposed. So second generation rodenticides cannot be utilized legally in these formats. They cannot be utilized in power pole protection, or timberlands cannot use it. So, for example, locally, Green Diamond, Humboldt Redwood Company, they can't use second generations. It's illegal for them. And also consulting with them, as well as consulting with the Department of Pesticide and Regulation and their database, none of these instances were factors. The next thing is marijuana cultivation. Some local law enforcement officials knew that we were doing this study, knew that we were having rodenticide deaths, and they brought us in to consult with them, and they showed us photos of what they were encountering within our fisher project areas and adjacent to our fisher project areas. And a good example is this lower photo, that this particular site had 90 pounds of rodenticide distributed freely on the ground. That's a significant amount of rodenticide. It had 10 of these 9-pound buckets up there. So further illustrating or documenting this is we started running into these grow sites within fisher habitat. We tend to, as ecologists, when we run into a grow site, we'll do a 180 and move out. But with encouragement of Mark and some local law enforcement officials, we decided to address this concern because this was impacting what many of us have invested years, and I know some of you in this audience have invested decades to conserve these species for recovery off of either species that are on the list of for recovery on the Endangered Species Act or species that are candidate. We've spent decades to try to recover these species. So this is a good example of the toxicants found, and I've actually put on the table, this is one site. This is only one site, and this is only 40 or 50% of one site, the amount of toxicants we found. If you wanted to come up, I would recommend also washing your hands post touching any of these. But you will see the bites. These are just rat poison. You'll see the tooth marks we removed from this within fisher habitat. Tooth marks and consumption, but also at the same point, these are fully intact packages of rodenticide in weather-resistant packages that we found, Mark and I have found in sites that when we find receipts, they've been dismantled for 1 or 2 years. So these packages are waiting for the next generation to consume them. So just to highlight also, where are these grow sites at? That one grow site where we had multiple pounds of rodenticide and other banned chemicals is where the red polygon is. All those black polygons are Fisher home ranges. Those yellow dots are northern spotted owl activity centers. That's only one site. There's multiple sites within this area, and there's a lot of potentially undocumented sites that haven't been accounted for. But again, that further solidifies that, that link. If they're not being used in any other manner, but we're finding pounds of this within these sites that are incorporated within these home ranges, it stronger supports what we've been concluding, that these are the contributing sources of exposures of these poisons. So when we go into these sites, this is what we're running into essentially. We run into, again, in this center photo, rat bait right next to plants. We're finding also large rat traps. And so the next step we've been doing is collecting these rat traps for forensic evidence, because these traps are found in the bushes. These traps are found with fur, blood splatters on them. So now the next step that we're doing is taking this in and starting to forensically analyze the tissue, the hair, or left behind on these traps, so we can start to quantify animals killed or maimed. And we wish it was only 2 or 3 rat traps, but the wrappers, we find maybe 15, 20 rat traps and wrappers that may account for more of them. Dead carcasses, that's me picking up a dead Steller's jay. We're picking up soil samples to start to analyze environmental fate at these sites. It's because if you put this rat bait out on the soil, the half-life stays the same. It can be 200, 300 days half-life in the soil. There's been documentation of insects that go through the soil, like earthworms or snails that go through the soil, will pick the toxicant up. And unfortunately, these rat baits do not inhibit clotting factors on invertebrates because they don't have clotting factors, they don't bleed. So they sequester it. So therefore, the next item that consumes that snail or earthworm can be exposed because they're consuming a prey item that has been exposed to these toxicants. The other thing, though, too, is remember, these sites are not 1 year, 2 years, or 3 years. They're there for multiple years. And there's so much trash left because they'll create a garbage area, then it gets filled up, they'll go create another garbage area. So when we go into these sites, we rummage. It's not the funnest job, but we rummage through this trash to start to try to document. And we find labels of toxicants. We find rat bait constantly in these trash bins. So if you have raw food there and you have flavorized bait, we would strongly suspect that most likely any carnivore or any wildlife species that comes into rummage, the encountering of a toxicant is likely. Again, this is part of that one grow site. So this is only one grow site in Northern California here. What we removed was 10.5 pounds of rat bait. So if I were to put the ecological quantification of this, that it would be thousands of deer mice, thousands of wood rats, thousands of gray squirrels that many species are very dependent on and part of their food web. And they're dependent on this for so many different parameters, and other species are. That, as you can also see, that if these prey items were exposed and poisoned, it could also potentially kill that, up to 47 martens. So if you have a Humboldt marten here locally that is being petitioned to be listed, and you have this potentially impacting that species, fishers, spotted owls, we have 2,700 pounds of fertilizer. Again, we haven't fully quantified this one site. This is all we've been able to do safely. And so there's most likely more than this, and this is a very conservative estimate. Again, poaching occurs too. So this is one of several deer carcasses found at these sites. So you're taking other prey items that are larger for other carnivores. You're taking opportunities, specifically this is on tribal lands. So you're taking opportunities for the Native Americans that are dependent on this food source. You have individuals that are taking without their permission. You have ringtail cats. It's a state protected species. We would wish that rodenticides were the only toxicant out there. Unfortunately, DDT that is banned in North America, or United States and Canada, has been found right in our backyards. We have organophosphates, concentrated organophosphates like malathion. It's concentrated enough that it's 50% that we find bottles, that one bottle is equivalent to 350 to 500 gallons worth of malathion to be sprayed, and we find multiple bottles of this right in coho-bearing streams, where there's also sensitive amphibian species. We're finding carbamates. These are banned chemicals in United States, Canada, and the European Union. They've been banned specifically for the impacts that they have on wildlife, impacts to humans, because it's a systemic poison that gets sucked up into the phloem and gets sequestered in fruiting parts. And they're using this very maliciously. And what I mean by maliciously is this lower photo here of this tuna can is actually pourable furadan. So it looks pink, and very similar to what has been done in other nations, because number one, they're tired of bears, deer, possibly fishers coming into their grow sites and damaging their plants. They're tired of those same species raiding their cash crops, or they're just tired of those animals walking into their grow sites. So what they do is they put maliciously this carbamate in food material like tuna and sardine cans and place it around the grow site to intentionally poison wildlife. And there's also metaldehyde. So this is a snail and slug bait that's placed out there as well. So besides those direct threats, the additional direct threats are armed individuals out there. So these aren't, everybody has this perception. When we've gone out of the Emerald Triangle, people have this perception that you're talking about marijuana growers. Aren't these really happy sitting on your back porch individuals? No, these are armed drug traffic organizations that are in our public lands on Native American lands. And you can see here, these are 8 individuals, and there's actually 12 guns within these 8 individuals. They unfortunately make the mistake of leaving their point and click cameras, so we get to look at those. So there's actually 9 individuals whoever took this photo. But that's a deer poached, and it's not just one deer. These guys get food drop-offs, and the carcasses that we find are, 10, 15 deer carcasses at one site that's been documented. And so they're supplementing their food resources out there. Poaching, again, these are, deer, these are male deer. If I were, I'm a hunter, and if I were to see those male deer, those are considered very large male deer. And those have been poached. Prey items being poached. Bear being poached. And these bear that they're finding, they'll take the paw pads. They're also using it for the black market, supplementing their besides illicit activity, they're also supplementing some of these carcasses for their black market value. Carnivores. You have ringtail cat, a gray fox. Again, remember, March and April, May is when these individuals are out there growing. They're getting a head start on this. They're poaching does. These does have not given birth. This is one of just numerous photos I have of does that have either aborted, or when they take the photos, these are fetuses that they remove out of these does. So they're now poaching does that haven't given birth and getting rid of the next cohort, the next generation. This is one of 3 endangered peninsular bighorn sheep that have been poached. There's one that has been shot, and this is one of 2 that are suspected to be poisoned. These people have spent millions of dollars, of conservation dollars, advocacy groups, environmental groups, state, federal agencies have spent millions of dollars to try to recover this endangered species. And you have a group out there that has suspectedly poisoned 2 and shot 1 and just left it there to rot. So another question is, you know, if what I'm portraying here, just a one instance, is it just 1, 2, 3, multiple instances, and is it just pulses in one year and goes away the next year? And what I'm going to highlight here is actually what we know of. And so these are actually, the polygons are actually national forests and parklands. And all we have is of 3 national forests, but I'm only going to highlight 2 of the national forests. And what I'm going to extrapolate from these 2 national forests is easily extrapolated to any of these other national forests or parks. 2005, 2010, there's 637 grow sites on the national forest that have been remediated. That's 637 dots where all these grow sites are. There's still 500 dots I have not incorporated on here that are grow sites that still need to be remediated. What I mean by remediated is there is, as the #1 toxicant out there, there's still 500 sites that still have the #1 toxicant, these rat poisons out there. Again, this is only Sierra National Forest and Sequoia National Forest. And many of us who are fishery ecologists in this group would look at these points and see a similarity of where fishers reside in these 2 national forests. It pretty much overlaps. Now, the additional indirect threats to wildlife is critical habitat or wildlife that's been lost from grow site-initiated fires. And what I mean by this is fires that have been investigated, that the investigators have found specifically that the fire was initiated by a grow site, an illegal grow site, and that's all that's incorporated. So it could be a illegal grow site from a campfire or actually a grower that illegally sets a fire that has happened here locally, sets a fire to burn out law enforcement that's coming out to eradicate them, or burn out another DTO that's in the adjacent watershed that's growing. So they have these retaliatory strikes. So what I'm going to show here is what we know of is that in Northern California, we have 3,500 acres, and the Central Sierras, we have 535. And you can see here we had a huge fire in the Southern California coast, close to 90,000 acres. So we're talking about a total of 93,000 acres. So in addition to these fires initiated and start, we have to think about the risk and consideration of local communities started by these fires, as well as the firefighters doing this. But the main thing that I wanted to highlight is that just alone on these fire totals and this cost are greater than $35 million. Now, when I look at where these fires and the shape files of where these fires are, and I extrapolate to see what species lived within these shape files, and I go to U.S. Fish and Wildlife Service's quad list of what species, either critical habitat or where the species actually reside in, these are the species that these fires, the habitat or directly impacted these species that the fires have had. Fisher, marbled murrelets, northern spotted owl, western yellow-billed cuckoos, California condors. That 90,000 acre burned up a significant portion of the California condor's critical habitat. California red-legged frog and mountain yellow-legged frogs. So these are the additional impacts that we are unforeseen what could occur from these illicit activities on these lands. Now, safety data and budget impacts from cultivation. you remember the photo I showed of 8 individuals. So one of the things that we have to take in consideration as ecologists or any ologist out there is our safety concerns. So the likelihood of running into armed growers out there is based off of those dots that I showed you, it's actually pretty strong. I mean, and the reason why I'm mentioning this is just going off of some significant instances. So these incidents, there's multiple ones I could have put on here. But in 2002, armed growers actually, with an assault rifle, shot at a federal biologist vehicle. 2009, this is a very scary situation. 2009, armed growers actually had a foot pursuit with a national forest biologist. They pursued this individual for over an hour and 20 minutes. For 40 minutes, this biologist lost radio contact with dispatch, where law enforcement and his direct supervisor initially thought that that individual was dead. And luckily for him, he was able to come out of that unscathed. In 2010, while a federal biologist was driving on the road, growers encountered him, blocked him in, interrogated him for over an hour, asked him what he's doing, getting his ID, documenting everything that he has, so that basically in an indirect way threatening that if anything were to occur to him, that there's a possibility of retribution. The same thing happened in 2011. Unfortunately for this instance, the individuals took a photo ID of that biologist's face, took a photo of his California's driver's license, and stated to him, if my grow gets taken out, I know where to go to. So there is a threat now to not just that individual, but a personal threat to that individual's family and loved ones. In 2012, Mark can testify what has happened to his field crew doing surveys out there. They have been shot at. So this is not just a 2008 or 2009 instance. This is multiple instances that have been going on. So when we put this all together and with interviews with other project biologists, is I'm asking them, I know what my encounters are with these armed individuals in grow sites. But I'm asking them, what is your encounters? And they're saying on a monthly basis, a weekly basis. Our biologists have so much fear and anxiety that is impacting their work. We are having biologists quit because they cannot handle the stress of going out on public lands and in having to deal with this. In talking with everybody, the one thing I get constantly is that we expect to instruct and guide students, interns, in our field crews to deal with threats such as poison oak, steep terrain, mountain lion or bear. We would have never envisioned or fathomed that any of us here that have had to go through the training or the SOPs, so the standard operating protocols, to explain, like, if you run into black piping, if you see an armed grower, this is what you're doing. And this is us explaining to them what happens on public, national forests, national parks, in tribal community lands. And personally, I'm not comfortable with having to explain that to my field crews. So data concerns. There's a loss of access. As I mentioned, these guys are armed. There's a loss of access for us to collect this data. So what this means is that when you go ahead and do any study, you might have control or randomized plots. And what I get constantly is our randomized plots fall into known growth sites or old growth sites that haven't been assessed yet. So now they have to actually take those random plots and have to put them in a place where it's considered safe. So now that impacts the data quality. Just recently, we had 2 fisher carcasses that were within a grow site. We couldn't access those fisher carcasses until law enforcement was able to make them safe. So we lost those 2 data points. And those 2 data points, I could suspect they might have been poached or killed or poisoned by those growers that were at those sites, but we would have no idea because we had to wait a couple months before it was considered safe and those carcasses were completely lost. So just again, just going with Fisher project areas is highlighting for these months. So the months of May and September, the grow months, it's average about 15 to 25% of the study area has been taken out. So if you had plots, vegetation plots, you had animals that died within that study area, you cannot enter about 15 to 25%. And that's what I'm getting from the Fisher project PIs. Now, budget concerns on conservation research is, again, these are safety issues. So you have to now think about, before when you go check a remote camera, you might have 1 or 2 individuals. I used to do it with just myself constantly. Telemetry by myself, field data collection by myself. Now we have to think about putting another individual with me as safety in numbers. So now you're talking extra vehicles, supplies, personnel, salary, benefits, all incorporated. So this is only 2 projects I'm incorporating this data. So one of the things is to take in consideration is this is not incorporating within the same area the owl crews, the workers that now need to be incorporated just because of extra personnel and extra vehicles. This money, and all of us in this field, we all know that we have very limited budget to spend towards conservation. This would be a significant budget for a research project, and that is being only incorporated due to safety concerns. Now, other unforeseen risk is, can game species that humans consume be exposed to any of these toxicants? And the answer is yes. Now, can humans who consume their meat be exposed? And there have been no studies to date that have looked at human exposure via these contaminations. However, again, it's biologically feasible for myself or any of us that consumes meat, being a predator, to consume an exposed prey item. But again, none of this data has been incorporated. So now we're looking past the wildlife aspect. We're now looking at the human health risk. So the next steps our group feels is, number 1, we need to generate more science-based information. That's to inform agencies, managers, and policymakers in order to create opportunities to educate the public. Unfortunately, we were blindsided with this in the last couple years, these impacts. Talking with law enforcement, it's been something that's been ongoing, but it's been exponentially getting worse. So presenting more information like our PLOS paper in a peer-reviewed science-based format, we feel is the next step, so that it also removes the sensationalism or the emotionalism and creates a neutral and objective format that people can scrutinize. And with that, we also are asking we need as researchers to collaborate with law enforcement. And the reason why I'm stating this is that we can't go into these grow sites alone to document what these impacts are. It's unsafe for us. It's also not law enforcement's mission to remove these poisons, or law enforcement's mission to document science. That's where we come in, or the remediation experts come in. So again, is bringing this collaboration together. And also it allows us to, Mark and I have ran into, when we go into these grow sites, we have our heads down collecting data. That's our focus. Heads down, collecting data, and unfortunately for us, what we're running into, we go back into these sites, and there's still growers out there, even though it's been eradicated. We run into these sites and we'll find new footprints. We'll find somebody who just finished taking a bath, and we just missed them. That happens regularly. And finally, creating mechanisms of support. There is no mechanism right now for us to put in for grants, or any type of support to continue this data collection. A lot of the research, the PLOS research, if you were to look on the front page, is there any funding that has been disclosed by authors? And there was no funding or no support to produce that PLOS paper. That paper was specifically funded or supported through volunteer time, as well as reallocating funding that these projects had already for another aspect or another tangent of their project. They had to divert funding to address this. There was no way, and there is still no granting opportunities for us to continue this research. So finally, we're looking at coupling eradication that's already ongoing on our public and tribal community lands. So coupling this with now documenting what these impacts, the environmental impacts that are occurring from these sites, and then also coming up with sound and just remediation techniques. So what we don't want to do is just go out there and collect the data and say, this is bad. We want to collect the data, determine what the impacts are, but at the same point, what we're coining as science with solutions is the solution is to now have sites that have been eradicated to remove these toxicants from them, from these sites, and removing that threat to wildlife and their ecosystems. So with that, I guess if we have time to possibly answer any questions.
I think we can open this up informally. I don't know if you'd like me to facilitate or if you want to, Mourad, or
It's up to you. I take it from the silence that this is probably a very, very downer talk.
First off, let's give Mourad a round of applause.
Well, one thing I would say too is that I know a lot of us, this seems very, very overwhelming. This seems like for many of us who have spent years or decades conserving wildlife or their ecosystems and their habitat, that this seems almost as a wall. And one thing I could just state is that unlike a stochastic event, I know some of you have heard this, but unlike a stochastic event, like a fire that has been sparked by lightning that we have no control of, this is a human-caused issue. And us as humans, we can come up with creative solutions to address this. So all is not lost.
Let's open it up to questions in the back here. Yeah, no.
Yes, thank you. Thanks for your great work. I really admire the presentation that you made and the passion with which you do your work. To me, this seems like an indictment of the drug war because the fact is that this is never going to stop as long as marijuana is illegal. We know that from decades of trying to limit the cultivation of this plant. It can't be done. My question is, in your conversations in Washington with the drug policy control administrators, did you ever present this information as an indictment of the eradication policies? Because it's a given that as long as there's eradication, the black market prices are going to result in this type of activity. And so now that people all over the world are calling for an end to a failed drug war, don't you think that it's the responsibility of people in an interdisciplinary setting like Humboldt State University to present this information in a realistic way? Because the fact is, it's never going to stop until we stop eradicating cannabis. And, you know, these are crime scenes that you're going to.
Yep. So
my second question is, are you at the crime scene when this material is discovered, or is it possible for law enforcement to plant this material in order to create animosity against cannabis growers, in order to to justify their budgets?
No, good question. So I would say your second question is yes. We have actually gone in directly on the heels in before or when the first boots are on the ground. And what we see there is exactly what we have seen at sites that we've been brought into, and also sites that we run into, and we let law enforcement know. We, like Mark and I, have gone into sites where we go in and say, his field crew has run into a grow site. Law enforcement had no idea about it. We go into these grow sites and we're finding this. So this is not planted material. The first part of your question is, I presented this as a neutral scientist, bringing the data only to the ONDCP, as well as the other agencies. Therefore, providing that information, providing educational opportunities like this, therefore, hopefully further perpetuating what may be additional creative solutions to address this through social or policy changes. That's something, as a scientist, I'm specifically only presenting the science and the impacts. In regards to potentially the legalization or the drug war that's occurring, I'm not addressing that at all because that's not my expertise and not my training.
We've got a question right here.
Yes.
So I have a question about how easily it is to obtain these second-generation anticoagulant rodenticides. I mean, you mentioned that timber companies aren't allowed to use them, so who are they being produced for? How are growers getting them so easily? And has there been any talk about limiting their availability? And it sounds like that rats have built up a lot of tolerance to them already, so that their effectiveness for...
Yeah, rats have built up tolerance to some second gens, but like Brudificum is something that is still very potent. Great question. So the question is what are the current regulations, as well as what is proposed future regulations that may limit it, and is this readily available, these toxicants? Previous to 2011 in June, EPA had the regulations that these could be sold at, let's say, locally here would be your hardware store, like Ace Hardware. Now, in order to deter the production of these small little 3-6 ounce packages, they've went ahead and stepped up the packaging from small packages to 8, 10, 15, 20 pound packages, and only sold at farm stores. So what the deterrent is that if you're going to place one package because you have let's say if you choose this method, you have one rodent problem at your house, are you going to pay $5 or $10 for a package, or are you going to go to a farm store and pay $40 for 20 pounds? So that was that deterrent, that price break deterrent. It's still, you can just go to any of your farm stores and buy those buckets. Currently right now, I was just having a discussion with Josh earlier, is that a lot of manufacturers, because of these regulations, are now suing state agencies that are regulating this as well as EPA to bring this back onto the market so it's readily available. But the other thing to take in consideration is that, let's just say we were to ban these chemicals. Hypothetically, if we were to ban these chemicals, I don't personally see that as a deterrent for this particular illicit use. And the reason why is because DDT, which is banned, is here. Carbamates, which are banned, are in our backyard here. And so banning a chemical doesn't seem to be the deterrent for some of these drug traffic organizations to utilize this to protect their crops.
So is DDT still legal in Mexico?
Yeah, I believe, I don't know south of the border I know that a lot of these carbamates are legal in Mexico, Central America, Africa, and other nations, or other continents. Yes?
Has Washington made any plans to implement new policies based on your information?
Let's just say that when Mark and I were just in DC, we presented at the ONDCP and other officials from the executive office, as well as other agency leads. A lot of this is new information. A lot of individuals are only aware of the eradication efforts, and there's the anecdotal, we saw one dead animal information. Quantification of this impact is key and essential, and I think when we presented it to them, many of them were surprised. And so I think, again, you know, this is that step forward and that step progress, that light at the end of the tunnel is utilizing this information that I presented, and other individuals are hopefully going to start working and presenting further, you know, addressing, you know, and bringing it to our policymakers, like this is going on in our public lands, the safety, the impacts. But yeah, in Washington, some of them were aware, while others were completely unaware.
In the back row.
Are there alternatives to lethal pesticides that could be mass marketed as opposed to these ones, so that even if, you know, the pot farmers still were looking for a pesticide, they wouldn't be using something that would kill instantly?
There is alternatives. There's some people suggested various powders or that are deterrents for rodents. There's also there's lethal but non-poisoning, like electrical shock traps. There's a whole bunch of websites that are available for non-lethal or lethal but non-poisoning deterrents. But again, if that might be something that we might utilize and we might make that choice at our home. But I seriously doubt, based off of some of these individuals that we've seen, that any of these individuals, that if we were to come up with a grow plan, like, please do not use these, I seriously doubt that those individuals will go, I'm not going to use decon, but I'm going to bring DDT. Okay, I think because it becomes again, here's the thing is that it's the use and misuse of our public resources specifically for the monetary gain of for an individual or an organization. So when that occurs, regulations sometimes get thrown out of the mix.
But that is an interesting point in terms of thinking about the different types of growers. You know, whether
Yes.
people are growing under the auspices of Prop 315 in California, whether somebody's growing for themselves, or growers that are trying to be more responsible in their practices. This conversation has occurred in the context of energy consumption. You know, how do you know whether you grow indoors or outdoors? Trying to dampen the costs, if you will, to the environment. There was a hand up back here. Yeah.
Yeah, what's the potential for these anticoagulant poisons to get into the waterways?
It would take a lot for it to dissipate into the water system to actually have an impact for an individual, whether human or wildlife, to drink from it. Some of the other chemicals is different. Some of the carbamates. The other thing, though, too, is that something that hasn't been analyzed yet, and we're hoping at some point in the near future, in the next grow season, to start acquiring this, is they put the cisterns. So they built up these watersheds, and what they do is they just put all these chemicals in as a slurry, and then pump it out to the plants. So you'll find all these chemicals nearby. Now that would be just that one particular water course that may be impacted, like if whatever herpetofauna may be there, or invertebrates, or if there's any salmon that's still alive. But for some of these chemicals, they dissipate fairly quickly. But the environmental fate in the soil, as I mentioned, is unknown.
Given what you just said, plus you have a couple of photos there where this stuff was just spread everywhere, right underneath the growing plants.
Yes.
Is there accumulation within the plants to the point where the person using this product would be impacted?
That's a great question, and I've talked to 2 human toxicologists and 3 wildlife toxicologists, and there is not one piece of data out there to say whether or not this can be sequestered in the plant. Nothing's been ever looked at. No experimental studies. So not just on the plants, the other question is too is, can these toxicants, because we're thinking not just the plants for the human or the consumptive value of someone might consume it, is what happens if the nearby adjacent mass-producing plant like a tan oak or a live oak can sequester it in the mass material? That's something that, that's, no one knows this.
Question in the back.
Yeah, this is a question about the reclamation or cleanup piece. And this summer there were some covers that seemed to indicate in the local papers that money primarily seemed to be an issue in terms of paying for adequate cleanup in sites after law enforcement has gone in.
Yeah.
And could you just comment on, is that sort of a primary piece in terms of having good reclamation done, or are there other pieces that need to come into play for those efforts to be good and thorough?
If I was a funder for a day, I would put equal funding towards the science documentation and equal funding towards the reclamation. And the reason why is, as I mentioned, is when we go in to these sites, it's not law enforcement's duty. So this actually was left behind because there's not enough individuals to remove it. It is, I mean, some of them don't know if this is toxic or not to leave behind. It might, does it go away in a day? And so there is absolutely no funding. You have to be creative in your funding grant writing opportunities. And as I mentioned, that group that we're working with, that is the reclamation team, that's done a lot, pretty much I would say has done probably over 75% of the reclamation in California. And that group is a volunteer group. And they essentially pay, I know that the executive director has mentioned to me that he's paid himself at $4 an hour because there is no funding. Peanut butter and jelly sandwiches and mac cheese is essentially the staple diet for these guys. But their primary focus is to remove these toxicants out of there. And so they still have 500 sites they know of that need this toxicant out. They're a volunteer team. They train individuals. And one of the things that we're trying to do is trying to bring these individuals to help reclaim some sites in Northern California. And that's where we're hoping that when we do this, that they can also possibly train a group here locally so that can be, various little satellite groups that can help remove this toxicant out.
Mourad, would you comment on the safety of all these passionate biologists now going out and finding these dump sites and digging through it to pull all this out and get it out of the environment? Would you suggest that that's not a very smart thing to do, since most people aren't trained to be safe around carbamates?
Oh yeah, that's one thing I am adamantly 100%, unless you've been properly trained and you know what these toxicants are, not removing this on your own. And the reason why is because, luckily for us, some of these are labeled. We've gone into grow sites where there's a bottle and we have no idea what it is. It's pink. It looks like Furidan. It could be Pepto-Bismol. It could be anything else, but I'm not going to touch it with a 10-foot pole because it's not labeled. I don't know what chemical intoxicant it is, and I'm not. And the other thing is too is hiking this out of that area. If like metaldehyde is the flaky snail and slug bait, it comes in bags, and some folks were suggested, I'll just put about 2 of these bags in my backpack. You trip and fall, and that aerosolizes it, and you inhale that. That is potentially a near fatal dosage, and so. These are chemicals that are specifically there to poison wildlife, or poison target species. So unless you're properly trained, I would strongly recommend not to touch this. And I think one of the things that we do with our field crews, and we do with, I know Mark does with students and interns, and we do the same thing, is you see it, you mark it, you notify your supervisor of what you saw. You don't, you just won't remove it. You're not, unless you've been trained to document it, then don't do it.
In your experience, what percentage would you say of the pesticides you find are imported from places where they are illegal to here where they're
We find rodenticides that have been brought in. So we find brodifacoum that you can buy normally, or snail and slug bait. This is actually another. It's a neurotoxin. We find this stuff in United States. It's manufactured here in the United States, but we also find the same chemical, the active ingredients, from other manufacturers outside of the United States. It all depends. It all depends on the DTO, so the nature of the drug traffic organization. They're unique. Some of them have a gravitation towards certain chemicals they really love, and some of them have a gravitation towards another chemical that they utilize. And I don't know if it's something that they're familiar with, or what they've used in their area, or if it's something that is just readily available. There's a palette of this stuff I can use. It's unknown, and that's intelligence from law enforcement, which I'm not actually dealing with.
Are there any sublethal doses showing up in other predators?
Actually, those exposures, the 79% that were exposed, those are all sublethal doses. So none of those are all doses that they were exposed to, but they didn't die specifically. They might have been chomped on by a mountain lion or a bobcat. So those are doses that were sequestered in the tissue. They weren't directly the contributing cause of mortality, the rodenticide. But for fishers, for a specific example for fishers, is that we had fishers that died with trace levels that were just a minute amount. We had fishers that died that had 1.8 parts per million, which is considered significant. And then we had fishers that died at 0.004 parts per million. So the range is up and down. And so now that's where that, it's not taking the consideration of just one toxicant, is that toxicant and maybe stressors. So one example is that, a really good clear example, which I didn't bring up in the talk, but I'll mention it now, is that in some of these experimental studies, for example, one experimental study, they had rabbits. And what they did was they brought in multiple rabbits. They gave them sublethal doses, and they found out that 1 out of 100 died. And they gave them ambient temperature, so like room temperature. Then they gave another batch of rabbits the same sublethal doses. Then they brought the temperature down to freezing or just above freezing. So now you have a stressor, an environmental stressor. Mortality rates jump from 40 to 60%. And so now we're thinking, is there potential of these sublethal doses actually contributing to another direct source of mortality? So the number one predation for fishers, number one cause of mortality for fishers is bobcat predation. Now, are bobcats really are just predating on fishers because there's an interaction, or are bobcats predating on fishers because fishers now have this sublethal dose and it's making them a little bit ataxic or wobbly? They don't have the energy. That's something that hasn't been teased apart yet, but we need to take those in consideration. Yes, all I can say right now is that we're looking at surrogate species such as barred owls for spotted owls, and it is showing up, and it's showing up in spotted owls too. So it's not, fishers are not the only ones. Spotted owls, barred owls, fishers, when you take it to that level, we have it in bobcats locally, that you could almost suspect that if you look at what the prey items for any of those species, then you would naturally make that logical conclusion that if they're whatever sharing that same prey resource, most likely has the same risk of exposure if they're incorporating that system.
We are about out of time here, so it's very clear that with Mourad's research, there's a lot more questions now that are being raised, and I hope for those of you who are students or future wildlife ecologists that this inspires your own research interests. For me as a sociologist, I find it interesting in terms of as we do bring some of these discussions back to thinking about how we talk about marijuana in our society, it's very clear that there's, at least from a federal perspective, and I know we've talked about it, that the feds are not necessarily able to, I mean, there was somebody who asked a question about the drug war. They're not able to lead the drug war on a morality front when you look at public opinion around this issue. And so there is an effort, and it gets a real dicey here, but there is a very explicit effort to frame this as an issue of environmental concern, because everybody is very concerned about this issue from an environmental standpoint. And from your research, they have very solid reason to be. So I just kind of wanted to point that out in terms of it gets really interesting when the feds suddenly become concerned about the environment in the context of destruction of public lands due to toxicants that are being brought in. But historically, there maybe was less concern with other industries. So things get a little messy. But clearly, there are a lot of questions, not as many answers. Mourad, I thank you so much. I mean, a lot of answers from your work. But thank you very much.
Thank you.